This is a walkthrough of Problem 3 on Exam 2 of Module 3 in the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 3, an experiment to determine the coefficients of friction between a box of cards on a metal track. The box is placed on the metal track. One end is tilted upward slowly until the box begins to slide. Once the box begins to slide, it takes 1.4 seconds for the box to slide 80 centimeters down the track. What is the static coefficient of friction between the box and the track? What is the kinetic coefficient of friction between the box and the track? Let's start with the diagram. There's our box of cards on the metal track. When it's tilted upward at 30 degrees, nothing happens, and then at 30 degrees it goes. It accelerates down the plane. The forces on the box are gravity, down, friction, up the plane, and the normal force, perpendicular to the plane. So the track's tilted upward at an angle of 30 degrees. The static frictional force can hang on to it no longer, and it slides down. That's the situation. The angle of 30 degrees is where the static frictional force is a maximum. It reached the maximum. We can write frictional force equals mu static Fn at 30 degrees. Before 30 degrees, the frictional force is less than mu static N. Mu static N is the biggest the static coefficient of friction, static frictional force can get. Just before the box begins to slide, the sum of the forces on it is 0. Nothing's happening. To set the forces equal to 0 with trig, we're going to choose a coordinate system in which the x-axis is down the plane. Like this. There's our coordinate system. Y is perpendicular to the plane, x is along the plane. Now we're going to take that gravitational force, which is neither along the x or y axis, and put it along the x or y axis. We're going to get the components of the gravitational force in the x direction and in the y direction. We need this angle right here. That's 30 degrees. This is 30, that's 60. The angle between the x and the y axis is, of course, 90 degrees, so that's 30 again. So the component along the x-axis is F gravity sine 30, and along the y-axis is F gravity cosine 30. There are the equations, and now we can change the force diagram. We can take that F gravity and make it this. F gravity sub x, F gravity sub y, F gravity sub x is mg sine 30 down the plane, and F gravity sub y is mg cosine 30, perpendicular to the plane. Before, after. Now it's easy to see, with the forces balancing in the x direction and y direction, what the equations become. In the x direction, we have F gravity sub x equals the frictional force, and remember the frictional force is a maximum, mu static F sub n. In the y direction, we have F sub n balances the normal force. Balances F gravity sub y. So we can combine these two expressions and stick in the mg cosine 30s and sine 30 and get that. And now we're done. We just have to solve for mu sub s. mg's cancel. Divide both sides by cosine 30. Mu sub s is tangent 30. Getting out the calculator, we see that it's 0.577, which we round to 0.58. Part B asks for the coefficient of kinetic friction, which is when it's sliding. As soon as the block starts to slide, the frictional force goes from mu static Fn to mu kinetic Fn. Since mu kinetic is less than mu static, the frictional force gets smaller. Let's shrink this on the diagram. We'll just take this arrow, shrink it a little bit. Now this force is bigger than the frictional force. It's going to accelerate down the plane. The forces in the y direction still balance. The forces in the x direction do not. In the y direction, we have the same equation. F sub n balances F gravity sub y, which is mg cosine 30 degrees. In the x direction, we have F gravity sub x minus frictional force equals ma sub x. They don't balance. There's an acceleration. F gravity sub x is mg sine 30. The frictional force is mu kinetic Fn. We can substitute mg cosine 30 for Fn, that's the equation in the y direction, and we can get this. But we have two unknowns, a sub x and mu sub k. We need another equation. We can get that from the information given. It takes the box 1.4 seconds to slide 80 centimeters down the track. So now we can use kinematics, 1/2 at squared plus v initial xt. The distance is 0.8 meters. The time is 1.4 seconds. The initial speed is 0. We can solve for the acceleration. 0.816 meters per second squared. Now we can go back to our force equation. There it is, and stick in 0.816 meters per second squared for a sub x. And solve for mu k. 0.48, which is less than 0.577, which of course is good news because mu kinetic is less than mu static, and that's part B. And that's exam 2.